All right, so welcome to week 3 of CO246. Today we are going to talk about Apache Directives and administration. In short, Apache Directives are the configuration options that we have on the server itself. If you recall, last week we compiled Apache. All right. Does anybody remember the steps that we took to compile Apache and install it? Actually, make install is the command, but right. So, well, first of all, we downloaded Apache, right? Downloaded. Then we ran this command that decompressed it and unarchived it. It was tar-xzvf. Then we configured it. Then we compiled it, and then we said make install for the actual final installation step. And you will have time today to rerun through this step. The key file that was created during the process is httpd.conf. httpd stands for http daemon, and then conf is the configuration step. So at this point, I'm going to start my virtual machine, and I will rerun through this download installation lab, because to have this configuration file, I have to rerun through the lab. All right? So let's go ahead and do that. Let's start up our virtual machines. And from then, we will be able to talk about directives and administration. So let's see. A virtual machine will be in the Programs menu. And I'll select the Ubuntu option. If you have a CD, you can go ahead and put it in the drive. Otherwise, you can, of course, use the ISO that we downloaded. Okay. All right, perfect. All right, so now the NAPIC system is starting up. If you want to, and I see that you're running the Fedora system, which is fine for the 232 class, it will work right up to probably week 10 or so. In week 10, when we talk about OpenSSL, you'll probably have to go back to the NAPIC system, but for now it is fine. All right. Okay. So let's rerun through the steps of the lab. By the way, the steps are inside of Blackboard, right? So the steps are inside of Blackboard. Let me log into CO246. And I'm going to download Apache, save that. That's very good. And okay, so far I downloaded Apache. You can download it with wget. You can download it with any browser. Next, I'm going to go ahead and decompress and unarchive my system. From here, I'll go ahead and run the configure steps. All right, and you will have plenty of time today to catch up with me to make sure that you can manipulate the config file, even though really next week we'll have the entire period for the lab and modifying the directives per steps of our lab. Yes. Yeah, this looks fine. Yeah. It's still loading. The icons will be there momentarily. Actually, Kelly, you can go ahead and close it right here. Control-Alt will pop you out of there. There you go. Okay, excellent. All right, so my step of configuration is done. I'll go ahead and complete this. So, whoops. Okay. That's okay. What's happening here is I actually am using a different version of the system that we used last week. Say it again? Yes, the detailed commands are actually right inside of Blackboard. But let me set up this system right here, and we'll resume discussion on directives. HTTP. Perfect. Okay, so if I can have your attention back here to the screen. What I'm doing right now is I'm editing the main configuration file, and I'll give you time in a moment to run through the lab and get it installed. The main configuration file is called httpd.conf, and what you will find in the configuration file are many lines that start with a pound. Anybody knows what those lines are that start with a pound? Comments, exactly. You'll find that there are more comment lines in this file than the actual configuration lines. Now, why do you think that comments are important? Exactly. So it is a self-documenting file. Think about it. For most other systems, you have to have a manual and then flip through the pages to see what a command does. Well, this is a self-documenting file, which means that right inside of it, you have all the information. So we start reading the comments by spotting that this is the Apache server configuration file. We can see that this version is 2.2 of the file of the server. And as we go down, we can see that there are sections of the file itself. The first section is the global environment section. In the global environment section, we're going to change things about the server that are very, very important, that affect the entire system. Then in the second section, there are parameters for the main or the default server, and then the last section is going to be for virtual hosts. Okay? So the entire administration of Apache are based on manipulation of this single file. Should be easy, right? If everything is in one place. And that's how it is. But there are programs, graphical user interfaces, that allow you to start up the program, and they will reach into this file, read in all the commands, and through the GUI you can manipulate this specific file. Okay? In this class, though, we're going to go right into the configuration file in order to be able to manipulate the source. All right, the first directive is called server tokens. So a directive is nothing else but a setting inside of the config file. If you know what the settings do, then you're managing, you're administering the Apache server. So server tokens are basically pieces of information that the HTTP header will include about our server. Let me give you an example of a server token. I'll grab a terminal, and I'll say wget-s spider4 www.grcc.edu. Okay. Last week we looked at the server tokens or the server headers, HTTP headers, when we talked about HTTP protocol. So notice there is a header here called server, and it includes Apache /1.3.31. See this one right here? That is a server token. Now, right now I'm giving away quite a bit of information about my server, right? Why some people, do you think, would choose to perhaps hide information about their server, hide the server token?
Well, first thing hackers do is try to recognize, to do reconnaissance to find out what you've got.
Yes.
That makes it work easier for them. This tells them that they don't need to look up IIS bugs or weaknesses. Just go straight to the Apache 1.3.
Exactly, and they can find the actual version of my server, they can look at the source code, and they can possibly find something that my server isn't doing well and then exploit it. So some people choose to use very limited server tokens. In the config file, you see, we have a few options. We can say this server token will only provide the operating system information. Is it Unix? Is it Windows? Okay. We can also look for other server token options. So let me start up Firefox here. All right, and this is going to take us to documentation and server tokens. Perfect. And these are the different server tokens that you can use on Apache server. So on our system currently, the server token OS is set. So it'll say it's Apache, Unix operating system, and the version of Apache. You can change it to MIN for minimal server token, meaning only Apache in its version. The minor or major version of it, and then finally you can go to the production server token that only says this is Apache. Okay? And the server token would be used when Netcraft puts together that nice graph that shows that Apache is the most popular system. Any questions about this directive, server tokens? Pretty straightforward. What can you do in order to hide server tokens completely? Well, actually, there's always here's the thing. If you comment a directive, oftentimes the default is going to be set. Okay? What you can do is you can go to the source code of Apache. You can then manipulate. I mean, you can put your name in it if you'd like to, right? But you have to do it at the source code. Then you compile, then you install, and then you have whatever server tokens you choose. So that's the benefit of being able to go right even below the configuration that the developers allowed for us. All right, so that's the first directive. And again, directives, they may sound a little bit scary, but all they are just settings inside of the file that are meaningful to Apache. If we go down to the next directive, which is the server root, this directive specifically says where is our server installed. So in our Knoppix installation, you will see here /home/Knoppix/Apache. Okay? This is not the place where your HTML files or PHP files go. The htdocs directory is going to be defined further down. This is just our root directory for the server. All right, let's continue down. The third parameter or directive is the PID file. Anybody knows what PID stands for in Unix? Process ID, right, process ID. Process ID is a number. You see, in Unix, the developers chose to use numbers for everything, okay? Everything. So every program, when it starts, it gets a number. It's easy to manage programs when it's done that way. You can call up a number and you can say, stop this program. You can call up a number and say, set a high priority for CPU for this program. So PID is going to be a file on the file system. Okay, file on the file system, and this file will have a number inside of it. So if later on you would like to rotate log files, and rotation of log files involves stopping the program, copying logs, and moving them, and then restarting the program. You need to know what the PID of the program is. And so that's where the log rotate program would get the PID number. All right, the PID number. All right, so the first three directives, fairly straightforward, right? They're all easy. Okay, they're not very difficult. All you have to do is just copy the name of the directive, Google it, and as long as you're in apache.org under documents, you're okay. All right. Plus, we have information right inside of the file that explains the details of it. All right. Next, we have timeout. So the timeout of 60 seconds, it is a long period of time for a user to be staring at a screen, right? If you close your eyes and you sort of wait for 5 seconds, it is a really long time. In performance of web servers, the rule is that if something is longer than 7 seconds, the user will likely give up on it. So if your web page does not come down and render in 7 seconds, users will start feeling like there is a performance issue here, something is wrong, should I press refresh, should I hit the button again? All right. So 60 seconds is timeout, which is long enough for the server to basically give up on the connection. So that's what this timeout stands for. Then we have the Keepalive directive, which basically says, should we try to maintain requests between, maintain connections between requests? This is not as important over HTTP, but when we get to HTTPS, it'll be very important that we maintain those connections. Why? Because when you establish an SSL connection, there's an overhead both on the server and on the client to do a lot of CPU work around cryptography, around encryption that takes place. And so to avoid redoing it every time you run into a session, we're going to maintain it. Here's the reason why. When you look at any web page, and now I'll go back to our homepage for GRCC. When you go to view source, the first thing you might notice is that there are all these other files that are being referenced, perhaps images. Okay, web pages today are not delivered in a single file. They have all these other references. So when Apache allows the browser to download the main page, the browser turns it around and it continues to request every one of these files separately. It says, please give me the image file. Please give me this Java script file. Give me that CSS. So it'll create many, many requests per each page that you're viewing. So when you have SSL established, it would be really, really nice if you did not have to renegotiate security for every one of those files that's created. So what we do is we open the secure connection, we keep the connection open, and then you download as many files as you want over that connection, and then we can close the connection. All right? But this is how HTML pages look like today. They basically reference you everywhere, all over the internet. Oftentimes, not just this specific server, but they may take maybe a page counter from some website, right? Or maybe Google Analytics, download that from Google. So all of those are referenced via some JavaScript and take you all over the place, which is why oftentimes you see web pages today download a little bit slower, even though your connection at home is very, very fast. And that's because so many different links are involved in downloading a page. Yes, Kelly?
Do cookies help you to be able to do that faster?
No, cookies would help you with customization that needs to be done to the page. So let's say that in Google you looked for 2 different keywords. Google can put those keywords in a cookie. So next time you visit their web page, you start typing something, they can put in what you typed in before. And this information will come from a cookie. But to speed up performance, there's a different trick that's used. To speed up performance, every one of these files, okay, can be optimized by removing all spaces, by removing new line characters, and then the file is smaller. So you have this whole process of running a JavaScript through an optimization program, and then the browser itself can decompress it from a deflate or a gzip algorithm. So in addition to optimizing it and making it smaller by removing characters, the server can compress it into zip. And so then when the browser downloads all these files, they're all compressed into zip files and then decompressed by the browser. So there's all kinds of ways of speeding that up. Another way of speeding up these types of connected files is through caching. So the first time you downloaded it, the chances of some of these files changing, like jQuery, right? The chances of it changing are small, maybe in the next 24 hours. So the browser will save it locally. Next time you ask for this page, it is not going to re-download this JavaScript. It'll just keep it and just render it right from your cache directory, which is why oftentimes you go back and you delete all the cached files, and because something didn't work. Your web page doesn't work correctly, you go to clear all the caches. Yeah. Okay, so that's why we would like to maintain connection so that multiple requests can be delivered via the same connection. For us, Keepalive is actually off, all right? And so that's just how it's set on the server. Next, max Keepalive requests. It simply says, okay, now that we keep this connection open, reasonably, how many requests should we allow before we renegotiate some of the security settings? And so you come up with a number, and the bottom line is that Apache and the config file out of the box is going to have a lot of defaults. And these defaults represent years of experience of Apache Foundation developers. So they try to hit middle of the road, make sure that it works for most people. And it will work for us at the beginning as well. Perfect. Now we have Keepalive timeout, which is the number of seconds to wait for the next request from the same client on the same connection. If you do not request a restore within 5 seconds, the expectation is that you have completed this connection, and so we will have to reestablish connection next time. Okay, so these were very generic global, yes? Keepalive, let's see, timeout right here. This actually, okay, so this directive sets Keepalive for a connection, whether to actually do it or not in general. And this one sets the timeout for Keepalive. So if Keepalive is on, then within 5 seconds, we will terminate the connection if no requests are made. But the original timeout right here is actually independent of Keepalive altogether. So this timeout is for Apache in general. So let's say that Keepalive is off, this timeout is still active. None of these other settings are active with Keepalive off, right? So this Keepalive would activate Keepalive timeout for an established connection.
Okay, timeout itself is just for an establishing connection.
Exactly. So that's just in general, even if Keepalive is not, if it's not maintained. So sometimes you might see a message in the browser that says, connection to the server has timed out. The server is not responding in a time. Those are the generic timeouts that take place sometimes. And it usually is a problem with networking. Maybe there is a wireless connection that has a lot of interference. And so then you'll see some of those major timeouts kick in. Okay, next we have a few sections that look very similar. What it means is that they will have start servers, directives, max clients, but there are key differences here. First of all, they all start with if module statement. If module is a logical statement that says, if this module is compiled into Apache, then look at this configuration, okay? Now here are some of the examples of these if modules. You can say if module netware. So if you compiled your system for the netware operating system, then look at this configuration. Or if you compiled your system for the npm engine, which happens to be on Windows, then look at this configuration. For us, we have the pre-fork module compiled. So the configuration that will work for us is inside of this if statement. So in Apache, in addition to straight configuration directives that say this is your timeout or this is your server token, you can have logical statements that basically allow you to have all configuration in the same file, but only some of it applies to your installation. Now, how do I know what modules are installed on my system? Well, there's a command that you can run, And let's see, if I locate my Apache system, if you run the actual HTTPD system, you can, let's see, let me log in here. User bin. It seems my HTTP isn't really installed. Let's see. Yeah, so the command would be httpd-l, and it will then display whether you have pre-fork on, or you have netware, or if you have SSL already installed into your server. All right, so -l, we'll look at this command later on when we try to determine whether proxy module is installed. But that's how you would know which if statement is going to execute on your system. Let's see. All right, so which if statement executes on your system? So I mentioned that pre-fork is the system that is active on our servers, and pre-fork is very unique to Unix systems. Okay, pre-fork is going to exist only on Unix systems when you compile Apache, because on a Unix system, we use processes. So PID for a process, for process ID. When you start the system itself, the initial process that is booted is the kernel. Then the kernel starts the init process. Then the init process starts other programs. Okay, Apache is another program that gets started either by us manually or by a service, and from then on, Apache can start additional processes underneath itself. So these are the rules that Apache uses to start new processes. First of all, it says when Apache starts, make sure to start at least 8 other Apache servers. Okay? When you connect with a browser, you need 1 Apache process for every browser that connects to your system. Okay? So in this arrangement, you are ready to receive 8 requests at the same time. Then it says, okay, whatever happens when you run this system, make sure that you always have 5 processes available, however many requests you might have. So when you first start the server, it'll have 8, and when the first 4 users attach to the system, okay, you will end up having only 4 spare servers available. So Apache will start 1 more. Okay, and so now let's say that 20 users attach. Apache is going to start enough servers to satisfy those 20 users, and then 5 extra ones. So the idea is we want to have an overhead of the processes so that when other users attach to our system, we can work with them as well. It works this way until you have 20 spare servers. So you had a lot of users hit your system initially, maybe 50 users, 50 different browsers. You had 50 Apache servers plus 5 spare, and then maybe 20 of them are no longer requesting resources, so we stop their connection, and now we have all these servers available in addition to our spare servers. Apache is going to start killing, discontinuing the spare servers, and it'll go back to only having 5 spare servers. Does that make sense? All right, so Apache is going to, and here's Unix terminology that's difficult for us to swallow, okay? It kills the children processes that it starts, right? So it's going to do that because it's managing the performance of the operating system and its own performance. Instead of having 200 open processes that can do all kinds of things that are not good in terms of memory usage, in terms of activity on the system, it'll have only available a few. Okay, I've mentioned that years of experience of the Apache Foundation kicks in here. This actually works. All right, many large websites are running Apache, and so this simple algorithm seems to be working okay. Now you can, of course, tweak it. So if you feel like you have enough memory, you have enough CPU to have many spare resources, so you can start at 200 spare servers, or you can start 200 servers and have 50 required minimum spare servers, right? So you can then manipulate how this is going to work. So those are the 3 directives here. Yes, please, Paula, yes.
So once it kills the tips,
Yes.
can it resurrect them again once the demand is there?
Yes, so when it kills the child processes, it does not resurrect as in bring back the exact ones, but it is going to start new ones to reach the required numbers. Yeah. So if it starts with 8 and it has to always keep 5, then we have 10 other users. Then these users go away. It's going to discontinue 10 processes, and it doesn't mean that it stops the ones that it first started or last started. It's going to keep the numbers manageable and then restart new processes that look just like the ones that it just killed, right? So they're all the same as far as the code that they're running. Think about Matrix and the agents running around, right? So they're all the same once you start them. So the processes are managed by these directives, and it works well. It's called pre-fork because in Unix, the process of creating new child programs is called forking a new process. So you have the main process is going to fork a copy or fork another program. It's going to basically duplicate. Okay, forking. All right. Then the additional directives like server limit simply means, okay, per process, how many connections can we have open? All right, per process. Then max clients. Okay, if our server is very busy and it's served already 256 connections, make sure to kill that one and start another one in its place. Okay, the World Wide Web it's a pretty wild place. So you not only have valid requests that are being made to Apache, but you have browsers that are requesting and they get stuck. Or maybe you have a DOS attack where this browser is just on purpose re-requesting your website. So in that case, these little servers are dealing with a lot of requests that may be not valid, that can be partial, that can just go on and on and on. Also, internally, there may be memory leaks. So again, the way Apache deals with that, it's going to recycle all the processes sooner or later, which keeps them fresh, keeps them clean, and keeps the memory out of leaks. Yeah. So it's a nice way of doing it. Other programs like Java will use garbage collection, right, where they will sort of recycle a memory. Yes, Terry. So, right. So, no, this is a good time to talk about memory leaks. So let's say that first let's define what a memory leak is. Memory leak is simply a program which has an error in it. So it's a program that might create a variable, and then in the loop, it continues to recreate that variable, therefore taking up more and more memory when it really shouldn't be doing that. Okay. Memory leak simply means that the longer you run this program, the more memory it's going to be taken up, and sooner or later it's going to stop your system. It's somehow going to, although it's often not done on purpose, right? So it's going to leak memory. It means it's not on purpose. It's a programming error. It apparently wasn't easy to find. Sometimes software is going to have a small memory usage problem, but when you rerun it millions of times, it becomes a huge leak. Yeah. Yeah. Do you recall getting your water bill and then Consumers Energy tells you if your pipe has this small of a hole, this is how much water you're going to lose over a period of time, right? So it's all it's not about the size of the leak, it's about how long that the leak is allowed, which is why, again, Apache is going to, every so many requests, it's going to stop a process and recycle it. So then, whatever the memory leak, it's going to at least be mitigated. It's not fixed, but we can recover the memory that the previous process was registering. Okay, and so that's the next variable, max requests per child. So every child will be killed after 4,000 requests. This is why Unix administrators have a great ego, and the most popular password is God. See, we give live, we take it away, and that's just how it is. Okay, the next set of directives in the worker.c relate to operating systems that have threads. Okay, if you have a process-based operating system like most Unix systems, you deal with a single process and you give resources to that. Windows, for example, is going to have threads. A single process is divided into multiple small pieces of CPU activity. So there is just different theory and I guess benefits of both threads and processes. Okay, with threads, you can make a better use of multi-CPU system because you can balance the threads across CPUs. When it comes to processes, it's easier to keep the system clean because when you kill one process, the entire process gets recycled. Again, there's a good case for both. Unix and Windows just implement this differently. Okay, so going down, here is a very, very important directive. The directive is called listen. This directive defines the port that Unix operating system is going to listen for requests for our Apache system. Does it make sense what the word port means in our discussion? How would you define a port? Okay, all right. So that's a good definition. Okay. Oh, where you dock your ship? Okay, very good. Yes. Access point. Yeah, yeah. Point of entry. Right. So a port number can range between 1 and 65,000. And this port number is going to be attached to an IP address, right? And then every IP address has a whole set of ports as well. Now here is the illustration that I would use. Imagine a skyscraper, okay, with many different windows. Every one of those windows can be a port. You can open it or close for some purpose. Some ports are more important than others. Basically, they are ports that have been defined through a standard, through some kind of an RFC. They've been defined as a standard for this type of a connection. So imagine in our skyscraper, there's the main door at the bottom. Okay, that's the important port. So port 80 is one of those main doors to the system. Everybody knows that when you look for a web page, you do that on port 80. So in the web browser, you don't have to type in www.grcc:80. You don't do that. You just say www.grc.edu, and the browser knows to go to port 80. But last week, when you compiled your servers, what was the port number that you had to use? 8080, yeah. And so we did that because you were running the system as the underprivileged NOPEX user, which teaches us another lesson about ports, that the super user can use ports below 1024. 1024 being sort of the upper limit of the standardized ports. And if you're trying to run an Apache server on port 80, you have to be super user. So port 80 is defined for us right here. Now, this listen directive is a little bit more complex than just the port. You can say, listen on this IP address and this port, because you might have multiple network cards. You may have a network card that just connects to the database server. And maybe this network card goes to our storage system. And then this network card has the public address that browsers are supposed to be touching. And when that happens, then you say, listen, IP address of the public IP and port 80. What do you think happens when you just say port 80 like this? Yeah, so it knows that you're not sure what you're doing. And so it'll just listen on all addresses, which sometimes is not what you want to really do. So the best practice here would be to put in the actual IP that you're listening on. All right, so listen 80. Let's go ahead and take about 5 minutes of break, and we'll resume our discussion on these directives.